this section, we're going to take a look at graphing and writing linear functions. So for the first example, we have the graph f of x equals 3x plus 2, and we want to compare that with the graph of g of x equals 3x. So remember, function notation is in the form of f of x or g of x, h of x, where before we'd be looking at something like an equation where y equals 2x plus 3. We just have like this linear equation here, and then we would graph it from there. Same kind of concept, but we just have this function notation, and a function is exactly an x value has exactly one y value, one output. So if I plug in an x value here, let's say like x equal to 1, I will get exactly one output. And in this case, when x equals 1, 3 times 1 is 3, 3 plus 2 is 5. So then I would come up with the ordered pair 1, 5. So this would be my x, this will be my y. So that f of x notation is in place of just saying y is equal to 2x plus 3, or whatever your equation or function is. So let's just graph these two and talk about the differences here. So the first one, I'm going to do this first line here, f of x equals 3x plus 2 in that color. So I'm going to go to this graph. Let's just use slope-intercept form. You could take like a table approach where you take a bunch of x values, plug it in. But you know what? Let's just do that. You know, I was going to use the slope-intercept form, and you could, but I want to talk about actually comparison here. So let's just take a couple x values. I'll take x equals -2, -1, 0, and 1, and we'll just go through those real quick. So when I plug in -2, I get 3 times -2 plus 2. 3 times -2 is -6, plus 2 is -4. And then 3 times -1 plus 2. So 3 times -1 is -3. -3 plus 2 is -1. Let's plug in 0. So 3 times 0 plus 2. 3 times 0 is 0. 0 plus 2 is 2. And 3 times 1. Plus 2. 3 times 1 is 3. 3 plus 2 is 5. So we get these ordered pairs, -2, -4, -1, -1, 0, 2, and 1, 5. You could have just used the slope-intercept form, y equals mx plus b to graph this, but there's a reason why I chose the ordered pairs, which I forgot about when I was originally doing this, but let's just go with it. So -2, -4, down here. -1, -1, right here. 0, 2, and 1, 5. So here is that function. Not my best line, but that's okay. Let's do the next one. So 3 of x. And we want to graph 3 of x, and notice the differences here. So I'm going to use the same x values. So I'm going to choose -2, -1, 0, and 1. And we'll talk about what happens here. So when I plug in 3 times -2, 3 times -2 is -6. And then let's do -1. 3 times -1. 3 times -1 is -3. 3 times 0 is 0. 3 times 1 is 3. So we get these ordered pairs, -2, -6. We get -1, -3. We get 0, 0, and we get 1, 3. So -2, -6. -1, -3. 0, 0, and 1, 3. So noticing the two lines here, it's really kind of hard to tell, but we know they're parallel. We know they're the same slope, and we can tell that right here, 3x and 3x. We know they're going to be going the same direction, doing the same thing. But the difference here is this one has this plus 2, where this one does not. It has, if you want to think of it as like a plus 0, the y-intercept would have been 0. So what did we do to all of our values here compared to here? On this one, we added 2 to each value. We just added that 2 on. So the difference here is that plus 2. What did that do to the graph? It shifted everything up those 2 units. So something to keep in mind how this function worked. It was the same base function of 3x, but everything was just shifted up vertically 2 units. And if we look at this point to this point, look at that 1, 2. This point to this point, 1, 2. It's all just being shifted up by these 2 units because of that plus 2. So it's just something to keep in mind. All right, so now let's write equations of the lines using function notation. Use function notation to write the equation of the line with the given slope and the y-intercept. We have a slope, we have y-intercept, 0, 3. So we want to use function notation here. So from before, if you remember from previous content, where you've done questions like this before with the given slope and y-intercept, where we just use that slope-intercept form, y equals mx plus b. And depending on what we're given, we might have to use point slope, or we might have to calculate slope. Like there's a lot of different forms that this could potentially take. The difference though, when we get this answer, since we want to use function notation, we're going to say f of x equals mx plus b. And in this specific problem, we're given the slope of -4 and we're given the y-intercept of 0, 3. So all we have to do is just translate this to f of x equals the slope of -4, x, because m is equal to slope, and b is equal to the y-intercept. So m is slope, which they gave us, is -4. The y-intercept is 0, 3. So that's just going to be plus 3. So our function notation is f of x equals -4x plus 3. And that one's pretty straightforward because we don't have to really calculate a whole lot. We're given the slope, we're given the y-intercept point blank, so we don't have to figure out anything. We just plug it into that function notation for slope-intercept form. Y equals mx plus b, so f of x equals mx plus b. Let's take a look at the next one. It says find an equation of the line with the given slope and containing the given point. Write the equation using function notation. So on this one, we are given slope and a point. This isn't the y-intercept, it's just a point. So now we have to use point slope. So we're using point slope form. What is point slope form? Point slope form is y minus y1 equals the slope times x minus the x1. Where this point that they give us, this is our ordered pair. So this is technically our x1 and y1. This is that ordered pair that we're given. And if we're given 2 points, we'd have to calculate slope using one of the points in order to get into the point slope. But we're just given a single point and the slope already. So the slope is 4, so that means m is equal to 4. So y minus 1 equals the slope of 4 times x minus the x1. So let's just plug it directly into point slope. I'm just using this form right here. And whenever we're done, whenever we get that final form, we're just going to translate it back to f of x equals whatever the answer comes out to be. So we just have to replace that y with f of x because y and f of x are serving as the same thing, just like how we talked about in this graph. So let's go ahead and solve this. I'm going to distribute the 4 into here. So y minus 1 equals 4 times x is 4x. 4 times -2 is -8. And then we want to get y by itself. So I'm going to add 1 to both sides. I get y equals 4x. -8 plus 1 is -7. So y equals 4x plus minus 7. Function notation though. So f of x equals 4x minus 7. And the reason that function notation is so important here is because a function means each x value has exactly one output. So when we're looking at applications with functions, it's really important to understand that if we're looking at some sort of like sales figure for the sales in a certain year, the output would be the sales, and it can't be multiple sales levels. It's just whatever that store sold in the year 2010, that's the output. That's what they sold. So you want to use function notation for those application type of scenarios. Let's take a look at the next one. It says find an equation of the line passing through the given points. Use function notation to write the equation. So this time we're given 2 points. Neither point is the slope or the y-intercept. So we have to do some work here. So first of all, we have to calculate the slope. Sorry, my pen is kind of delaying here. So the slope is y2 minus y1. My goodness, y1. Over x2 minus x1. So we have to calculate slope because we're not given that. We're just given the 2 points. So think of this visually. 3, 0 would be here. 5, 4 would be somewhere here. So the slope, so we were trying to figure out what is the slope between these 2 points. That's what we're trying to figure out right now. So we'd use the point slope, or I'm sorry, the slope formula, y2 minus y1 over x2 minus x1, where this is our first ordered pair, x1, y1, and then this would be our second ordered pair. So we just plug it into that slope formula. y2, 4 minus the y1 of 0 over x2, 5 minus the x1 of 3. 4 minus 0 is 4. 5 minus 3 is 2. 4 divided by 2 is 2. So we get this slope of 2 over 1, or just 2. So we calculate slope to be 2. And then from here, we have to plug it into point slope now, because I still need that form of f of x equals mx plus b. So I still need that slope-intercept form. So we're going to take that slope of 2. We're going to take this ordered pair of 3, 0. So y minus y1. And this is point slope, which I wrote down on the previous slide. So this is just point slope. So y minus y1 equals the slope times x minus the x1. And then just solve real fast. So distribute the 2. Y minus 0 is y equals 2 times x is 2x. 2 times negative 3 is negative 6. So y equals 2x minus 6. And then, probably shouldn't have boxed that up because I have to change it back to function notation. So f of x equals 2x minus 6. And some of these might get a little bit messy at times. Like you might have some fractions that you have to deal with. So just keep that in mind. Next two questions. Number 5 says, find the equation of the line through the point and parallel to that line. And then it says, find the equation of the line that is through that point and perpendicular to the other line. So let's first identify a couple key aspects. First of all, parallel. What does parallel mean? That means the slopes are the same. Two parallel lines, just like how we talked about on this little introduction example here, where we have 3x plus 2 and 3x. They're parallel lines. They're never going to cross. They have the same slope, but then that plus 2 is what the difference is. So we want to go through this point, and it's parallel to this. So that means our slopes are going to be the same. Well, what is the slope of this parallel line? This is already in the form of y equals mx plus b. So all I have to do is I have to just grab that slope form, that slope value, which is 4. So the slope is 4. So I'm going to take this slope, I'm going to take this point, and I'm going to plug it into point slope. So y minus y1, which this is our x1, this is our y1. So y minus y1 equals the slope of 4 times x minus the x1. And then we solve it. So distribute the 4. Y minus 4 equals 4 times x is 4x. 4 times negative 3 is negative 12. Add 4 to both sides. We get y equals 4x. Negative 12 plus 4 is negative 8. So let's change that back to function notation. So f of x equals 4x minus 8. So parallel, slopes are equal. The next one though, I already mentioned, this is going through a point and it's perpendicular to that line. So perpendicular, that means that we have negative reciprocals. So if we were to multiply the two slopes together, so m times m, if you want to think of it like that, it equals negative 1. There's negative reciprocals of one another. So let's get the slope off of this equation, but look, this equation here, let me scroll this down a little bit. This equation is not in the y equals mx plus b form. We have to get in that form because it's 6y. Y is not by itself. So let's divide everything by 6. So y equals x over 6 minus 12 divided by 6 is 2. And then the slope on this line is 1/6. Just grabbing that 1x over 6. So this is not the slope that we want to use for our new line, because that perpendicular means that the two lines cross at a right angle. So they cross at a right angle, meaning the slopes are negative reciprocals of one another. So this slope of 1/6 times some slope, we want it to be negative 1. So they're negative reciprocals of one another, so you don't have to like sit here and really rack your mind about this. Just understand that, well, if I have slope of 1/6, the negative reciprocal would be flipping the fraction, because it's a reciprocal, so we flip the fraction, so it becomes 6, and then we want the negative reciprocal, so that's negative 6. And what ends up happening when you multiply the two slopes together, 1/6 times -6, what does that equal? 1 times -6 is -6. 6 times 1 is 6. -6 over 6 is -1. So that's our negative reciprocal. So the slope that we're using is -6. So this new equation is going to have the slope of -6 because that is the negative reciprocal to the other line of 1/6. So we're using that slope of -6, and we want to go through this line, this point that is not a y-intercept or anything. So y minus y1 equals the slope of -6 times x minus the x1. Distribute the -6. This is going to be y plus 4, because it's minus a -4, equals -6 times x is -6x. -6 times -7 is positive 42. Minus 4, y equals -6x plus 38. 42 minus 4 is 38. So that is our equation. We want it in function notation. I guess it says find an equation. I believe the directions should have said function notation. I guess it didn't. I guess it depends. Sometimes it'll say equation, sometimes it'll take, but let's just pretend that it says equation and function. So this would just be f of x equals -6x plus 38. There you go. So key terms here, parallel, slopes are the same, and then perpendicular, the slopes are negative reciprocals of one another, meaning the slope times the slope is going to get you -1. So it's something to keep in mind there. So flip it, make it negative or make it positive if it is negative already. So hopefully this wasn't too much.